Hello and welcome to our discussion on descriptive statistics, specifically on how do we run some of these statistics in SPSS. So the format for the video that I'm making right now will be that I'm going to give you an example of what these descriptive statistics are and how they look in an actual Table 1 in a published article. And then we're going to look really quickly at some online data from the Department of Transportation that we actually can download as an Excel file. But then what we did for the purposes of this class is that we've converted that to an SPSS file, and I'll be using that data to demonstrate how to create all of these descriptive statistics in SPSS. As a quick review, we always think about the level of measurement as being nominal, ordinal, kind of this funny in-between category, or scale. Nominal and ordinal are categorical, not in order, and categorical, and they do have an order. Scale, remember, is like a little ruler, so we have, equal intervals as we go along. And then we have this funny category that's in between that is either the ordinal graduated, and because it has so many values, 8 or more, it starts behaving a little bit more like a scale variable, or a scale variable that got demoted because it's not normally distributed. And the reasons that it could be not normally distributed, as a quick review, it could have skew or it could have an outlier. This is harder than it looks because I'm drawing with my mouse. Outlier, I'll let that be an abbreviation. Okay, so if we have a scale variable, then the kinds of pictures that we make that go along with that are a histogram or a stem and leaf. If we have a nominal or ordinal, then typically we'll make either a bar graph or a pie graph. And if we have this in-between category, then that's where we're going to create these box plots. And also, then, in addition to the pictures, which everybody likes to see, we also report summary statistics, or these numbers, which take all of the data in the data set and summarize them in a much smaller or more manageable size. So for a scale variable, we report the mean and the standard deviation. Those are like twins. Whenever you see a mean, you typically see a standard deviation. So they go hand in hand. If we're looking at this in-between category, we would report typically a median and an interquartile range. And for the nominal and ordinal variables, we typically report n and percent of each of those categories. Remember, nominal and ordinal have categories, so we would say there are such and such number of people in this category, and that is something percent of the total. So those are the pictures and numbers that go with each of these different levels of measurement. So let's take a look at one in Table 1. And this is just an article that is on its way to being published. I believe it is November of, let's take a look at the date, 2016. So right about right now. So let's go ahead and scroll down to find the Table 1. You do not need to read all of these articles. Please don't spend your time reading them all through. The only reason that I included them is if you needed to look in the article somewhere to get a little bit more frame of reference, but we are not covering these articles as part of the class or any discussion that we're having. If we do, then I will definitely let you know to read that specific one. So here is a Table 1. And it is called Baseline Characteristics of Enrolled Study Participants. And very often that's exactly what a Table 1 is we want to be able to look and see what are the basic characteristics of the people who are in this study. It tells us something about the study itself, and people can use this to be able to decide if what the study found can be then applied to maybe my populations in my clinic that I have in a different location. And the thing that you'll notice about this particular study is that they've kind of broken it down into multiple different columns. And so here we have something called the ANBL. You'd have to read the article to know what that means. And a whole bunch, whoops, I'm not just highlighting this column, but underneath that, a whole bunch of statistics that go for that particular group. The next column just says for that ANBL group, how many participants actually had data. So there were 243 altogether, but not everybody has information for every single variable. Only 226 of those 243 had information on their age. And so a few people, we missed out on the data. It's incomplete. That's very common. And so you can see just how many people we have information on for each of these different variables. Then we have what's called the CBP group. That had 220 participants there. And then the fourth column is the participants that had available data in terms of the N. So 215 of those 220 had age information in that particular group. So that's oftentimes we're looking at table 1 for multiple participants. Now, the thing that I really like about this particular table, when I came across it, I said, okay, this is the one I'm going to use as my example, because it says age, years, so there's your flag that this is some kind of a scale variable, some kind of continuous variable, and then it says M for mean, and then in parentheses they put their standard deviation. So just right here it gives you all the information that you need to be able to interpret what these numbers mean. So this is my average age for this A and BL group, 45.43 years old, and then here's my standard deviation, 12.98, or approximately 13. And then this other group had an average age of 43.12, standard deviation of 13.22. When I look at those two numbers, that does not strike me as being unusually different. If you had one group that was 35 and another group that was 55, then the thing that you would be concerned about is that maybe you had some kind of findings in this particular research study because they were so different in age. That's why we're looking at this and being able to compare, is so that we can decide that sort of thing. Are they different because they were different in age? Probably not. So that's what we're looking at here. There are other variables that give you N and percent, and there are quite a few of them. Sometimes they will tell you the name of one of the groups, and if there are only two possible choices, female and male, they'll only give you the information for that one group, usually the most common. So here we have 72% of these participants were female, and here we have 77% of participants in this other group are female. Well, as long as we know the total number that we had information from, then we can subtract 167 from the 230 and figure out the percent that was male. So that's pretty straightforward. Partner spouse is a current smoker. Well, the other option is partner spouse is not a current smoker. Education, high school or more. Since they don't give us multiple categories in that particular demographic, in this table we can assume that they are just splitting it in, this is like a yes-no variable. High school or more, yes. Less than high school would be the other approximately 14.8%. So here we have weight in pounds, and again we're back to mean and standard deviation, and then here we have our BMI with a mean and standard deviation. So these are the kinds of things that you can find in a table, and I really like it when tables have the N and percent and the mean and standard deviation. If we go back to here we have our mean and standard deviation, here we have our N and percent. It's pretty rare for them to report medians and interquartile ranges, even if they should have. So if you find an article that does that, that'd be awesome. You can see basically how they've reported that. I don't have a good one readily available. So there's an example of a table 1. Again, please do not read through all of the articles. It's not necessary. The next thing we're going to do is we're going to look at some online data. And it's really common nowadays for you to literally just be able to go straight to the website and download, like right here, it says download a spreadsheet with the complete data set. And I did that, and here is said spreadsheet. It's labeled THT Data 508. And this is going to look very similar to what you're going to see in SPSS, so I just wanted to point out a few things here. Here we have all the different states. This is our unit of measure. In other words, for Alabama, Here's some information about commute mode share for auto, the raw value. So 95% of commutes are by automobile. And then they created these neat scores out of that, ranging all the way, I think, pretty much from 0 to 100. Here's the lowest, New York, 61.2% of commutes are by automobile, and that gets them a score of 100. If you have a really high automobile commute score, then that's considered to be not as progressive. And so then here we have a score of 5, so you can kind of see the range there. The thing that I wanted to point out is that here we have two variables called complete streets policies raw value and complete streets policies score. The raw value is either no policy or policy in place. And when we created the SPSS data set from this Excel sheet, we basically just converted it over. It deleted everything in this whole entire column. So you still have the score over here as 0 and 100, but it's not really obvious what that score means. So now you know that a score of 0 is equal to no policy, and a score of 100 is equal to policy in place. And so those are really the only two choices. It's either a 0 or 100. So you can kind of see where that came from. This data set has 41 variables. You're going to have a chance to look at all of them when we get to our SPSS data set. So let's go ahead and move on to that. And so what I've done is created an SPSS data set called dot.sav and opened it in SPSS, and here it is. It usually takes a minute to open, so go ahead and pause the video and open your own data set so you can be following along. Here you see that same exact information, state, CMS auto raw, here's the auto score. And remember how Alabama had 95% of commute was by auto, and that was a score of 5.3. I think if we scroll down a tiny bit, we get to New York. And here we have 61% by auto, and that's a score of 100. So you get the idea that they've taken these percentages and converted them over to some kind of a score from 0 to 100. There are also how much of the transportation was due to public transit, by bicycle, by walking, and then if we scroll over to the right just a tiny bit, here's our complete streets raw. You'll see that it basically deleted everything there, but complete streets score, and those are all 0s or 100s. You're going to have to go in to the variable view and tell it, what does 0 mean? What does 100 mean? Because now you've seen the Excel spreadsheet where the original data came from, and you know what those 0s and 100s mean. So let's go ahead and quickly review here. For a scale variable, we want to create a histogram and a mean standard deviation. You guys already know how to make a histogram, so I'm going to move right into how would you calculate a mean and a standard deviation in SPSS. And so here we are in SPSS. The majority of what you're going to do is going to be under Analyze and Graphs. So under Analyze, that's where we are going to be able to do some descriptive statistics. And remember, you want a mean and a standard deviation. Now, SPSS does its best to try to prompt you with these little pictures. And if you look at the picture here next to descriptives, this little symbol that's a mu and this little symbol that's a sigma stand for mean and standard deviation in statistics language. And so if you know here you have a scale variable and you need to create a mean and standard deviation, then this little picture next to descriptives is here to remind you that that's where you can do this the most easily. So let's go ahead and click on descriptives, and I'm just going to take this top variable in the data set, CMS auto raw. And so I'm going to go ahead and move that over as a variable. And I want to show you around this dialog box called descriptives. Under options, you can actually choose a variety of different things. Now remember that mean and standard deviation is really what we're after. So you could even get rid of minimum and maximum, but I like leaving them there just because that is helpful sometimes in being able to see how that variable behaves. So I'm going to go ahead and leave them there and click on Continue. You can kind of hunt around in terms of style. There's really nothing there that we need. In Bootstrap, we don't do anything in this class. So I'm going to go ahead and click on OK. And here it is. I have my minimum of 61, maximum of 95, with a mean of 87.9, approximately 88, and a standard deviation of 5.5. Okay, well, that's kind of good information. So that would be what I would put into my data set. I would have a variable for that. I would put a mean and standard deviation, and I would put those two values right here. So let's go ahead and try something else. Let's make the histogram for that particular variable. So I'm going to go to Chart Builder, and here I have my CMS Auto Raw. I want to make a histogram because it is a scale variable, and I'm going to drag my variable down here to the x-axis and click on OK. Now the first thing that you should notice about this variable is that it has this magic little value all the way down at the bottom. It's like, okay, what did we learn about having outliers and skewed data? This doesn't exactly look like it's completely bell-shaped. So maybe there's a little bit of skew there. So for the purpose of learning about box plots and interquartile range, let me go ahead and show you how to make those for this particular variable. If you go to Analyze, Descriptive Statistics, and right below Descriptives, there's something called Explore. This is like a beefed up version of the one that we did before. Not only can I look at different variables, but I can look at them across different categories or factors. Remember, factor is just another fancy statistic term for categories. So I'm going to take this CMS Auto score and put it in my dependents list. And if I go to statistics, you'll see that all I get to do is everything. It doesn't really give me a lot of options. I'm going to also choose percentiles just for the sake of being able to look at those. I could click on outliers. I won't this time. And under plots, you'll notice here's the stem and leaf. I could add a histogram. But the thing about this is you'll notice there is no box plot. However, when you run Explore, it automatically creates one. So I'm not sure why they didn't put it there as a default that you could uncheck. So in any case, I'll click on OK, or Continue, and then OK. And here we have the descriptive statistics that were created by doing this. And you'll notice here's my mean, 87.9. I just did that, so it kind of automatically created that. Here I have my median, 89.3. Remember how in statistics, if the mean is significantly less than the median, that tells me that I have left skew. So that is true for this case as well. We have that one outlier that's really pulling that mean down. Also, here's my interquartile range is 6.5. And what I'd like to do is actually create a frequency table so that you can see what that looks like. So let's go ahead and go to Analyze, Descriptive Statistics, and Frequencies. And so now you've learned three things under Analyze. Under Statistics, I can choose to ask for quartiles, and I can also select the median here. So let's go ahead and just do those two things and continue. And under charts, I can ask for all different kinds of things, bar charts, pie charts, histogram. I won't ask for any of those this time, and I'll just click on OK. And what you'll see here is I have my median again. So there are just all these different ways of getting to the same number, 89.312. There's the median, and here's my quartiles. Remember, I asked for quartiles. So I have my 25th percentile, my 50th percentile, which is exactly the same as my median, 89.312, and then the 75th percentile, or quartile 3, which is 91.665. If I were to take this 91.665 and subtract 85.184, the 75th minus the 25th percentile is the definition of this interquartile range that we have a number here, 6.5. Now here they've rounded all of these to the 10th, so your number, if you were to calculate it here, would be a tiny bit more accurate. And you also see the 50 states all lined up in a row right here, starting, and the frequency of each category is 1, I think, pretty sure. And so it goes all the way, I'm scrolling down, all the way down to the bottom. So all 50 states, and it gives you the actual numbers for those. And that makes for a very long table. And this is a data set with only 50 cases, only 50 states. So you can imagine if you were to accidentally create this table and you had 2,000 cases or 15,000 cases, it would just go on and on and on and on and on forever. So you normally don't want to do that, but you could find in here where is the middle value, 89.312. And the way we would find it would be to count 25 in from one end, and then the average would be between, it's probably somewhere in here, the average would be between whatever those two adjacent scores. I'm not sure exactly where it is because we don't get very many decimal points out here. But wherever that is, it's going to be between those two middle values because the median, because there's an even number of cases. So that's where you found the median. The same thing would be true then of the bottom 25. You would find the middle value, and the top 25 you would find the middle value, and that's exactly where the 85.184 and the 91.665 came from. Is literally, we're chopping that data set into 4 equal pieces and finding the location where that marks those, the division between them. So that's how you make a median and interquartile range, how you make a box plot. Let's take a look at the box plot. I'm not sure I looked at that with you. Here it is. There's the box plot. And so here's those. If you were to travel over here to the left, this median, the top, the 75th percentile and the 25th percentile would be exactly the same as what you saw with these numbers right here, 85.184, 91.665, and the 89.312. And then the whiskers extend out to the most extreme value that is not farther than 1.5 times the width of this box. Now we do have a case that's way down here at the bottom, number 32. If I went back to my data set and I found number 32, that would be New York. So see how here I have the 61.2% travel by auto. That's that value. So, oops. Let me get back to my box plot. I've opened so many things I can't get to where I'm going. Okay, so I need to close that. So that tells me that this is not only an outlier but an extreme value. So any value that's beyond 3 widths of the box, which would probably be right about in here, is considered extreme, and here we have it designated by a little star. So that's what the box plot looks like. Now, in terms of the last thing that I want to show you, which is this whole idea of n and percent, there are a lot of examples in our table where we have, here's the pharmacotherapy dispensed, n and percent. So the first number here is the n, the second number here is the percent. The first number here is n, the second number here is percent. All these n's should add up to the 243, and all of the percents should add up to 100. Now, because of rounding, it might be off a tiny bit, but if we added up 32 and 42 and 2 and 5 and 18, roughly, that should get us 100% because that's all of the possible categories. So this is a good example of a category that's spread out over more than 2. Remember how we looked at Female only had 2 possible choices, so they only reported one of them. So the pharmacotherapy is an example of that. So in this particular case, we do not have very many variables in this data set that lend themselves to frequencies and percents. So I'm going to go ahead and use the one that I do know about. Let's go ahead and go to Analyze, Descriptive Statistics, and Frequencies. And when I make this table, I want you to notice some things that are missing because you're going to be making the same table, only fixing those problems. So see here to the left, it's counting 1, 2, 3. That's telling us that we're making a frequency table. So we're counting the number. So let's go ahead and put in the complete streets, and this is the score, complete street score. Let's go back to statistics and not do quartiles and median because we don't need those. And let's go ahead and just make our regular tables. So here this tells me that for complete street score, I have 24 zeros and 26 hundreds. Now, do you remember what the zeros stood for and what the hundreds stood for? Because if somebody saw this table, they would have no idea what those meant. When you're taking this information and putting it into a table that looks like this, it should not say 0 and 100. It should have a label that actually describes what those mean. And then here's where your 24 and 26 would go. Then you need to fill this in with the actual percentages. And this is a simple case, so you could probably figure out that 24 out of 50 is 48%. But if it was harder than that, then this valid percent column would actually tell you, and it would break it down for you what percent goes with each of those frequencies. So that concludes my overview of statistics that goes along with the lesson that we're learning now. I hope this has been helpful.